So we're going to talk about adding and subtracting decimals today, and this is going to look really similar to what you've done before. Before we got started, we had done a subtraction problem with decimals with zeros at the top. I just want to review some strategies for taking care of those zeros. So the most important rule when you're adding and subtracting decimals is you have to line up the decimals. If you don't line them up, it's going to be very bad. So we need to make sure our decimals are lined up. And sometimes you'll have a problem that looks like this. What do you notice about that subtraction problem? Yes, Colson?
There's a whole number being subtracted by a decimal number.
The first one is a whole number, and the next one has decimal place value spots. Let me show you what I get a whole lot. I'm going to put the wrong way over here so you don't accidentally do it. But this is what I see with 5th graders. What's wrong with that? Yes, ma'am.
They're putting the whole number as two tenths and not the whole number.
Well, not even 2/10 because there's no decimal there. Is this going to give me a really, really messed up answer?
Yeah.
You cannot switch the order, okay? When you're adding and multiplying, remember our commutative property, they can get in their cars and drive around and move to different spots. Not with subtraction. This is 20 minus 4 7/78. You cannot put the 20 at the bottom. This will lead you down a very wrong path. If I estimate 20 minus 4 7/78, what's 4 7/78 closest to? What would I round it to? 5. So my answer is going to have to be around 15. 20 minus 5 is 15. Would my estimate match anything here, anywhere close to what I was supposed to be?
No.
So estimating is going to come in handy because every once in a while I'll have somebody who's really good at doing this, but then they flip things around. So what do you think I should do with this 20? What does he need?
A decimal.
Lila?
He needs a decimal.
Does he have a decimal?
Mm-hmm.
It's just invisible. Can I bring it back out?
Yeah.
So he takes off his invisibility cloak and it's right there, like Harry Potter. And something else we can do is use our line paper sideways. And I can line up the dots on the lines, and that way I can keep my place value in order. Can I subtract this problem right now? Or do I need something else? I need some zeros there. Have we put happy little zeros in our problems before?
Yeah.
Yeah. So all I'm going to do is throw these guys in. Now, when we did the problem before, a lot of you showed me that you knew how to cross out the numbers and borrow from the tens to the ones to the tenths and then to the hundredths, and then we can subtract. But I'm going to show you another way. This is not the wrong answer, but there's another way you can do these problems. If I have a decimal number with a lot of zeros, if you think about this like money, it helps even more. I'm going to take a penny off of the top number and the bottom number. Just a penny. And I'm going to rewrite this again. If you have $20 and I take away a penny, how much money do you have? $19.99. Pretty easy. If you have $4.78 and I take away a penny, how much money do you have? $4.77. Watch this. Did I get the same answer?
Yeah.
I know. Mind blowing.
Yeah.
How does this work? Well, if I have a tower of 5 blocks and a tower with 3 blocks, what's the difference between those two towers? How many blocks? 2, because you guys know that 5 minus 3 is 2. Well, what if I took off one of these blocks and I got rid of it and I take one off of this, and now I have 2 blocks and this is 4 blocks.
It's still 2.
Is the difference still 2?
Yes.
Because you're taking the same off.
If you take the same amount off each side, the difference will still be the same. You can do this for any problem, any subtraction problem. You have zeros at the top and you don't feel like crossing out all that business and doing all that work. I could take one off the top and one off the bottom. 7,999 minus 4,742 will give me the exact same thing without crossing off all the zeros. But you have to take one off the top and one off the bottom. Otherwise it won't work. Okay? But changing the number of blocks in the tower, as soon as I take one off, the difference is the same. You're just balancing them out and keeping yourself from having to do all the zeros. Yeah. I used to teach it to my third graders.